Hi. So when I was making last clip about why databases are not written in Java, in particular or .NET, I was partially thinking on other situations, and now I can make more clips. And I was thinking one case which is very surprising because it was kind of promoted originally like it would be possible to be done with Java. And for many people, they don't know even what I'm talking about. Who would write a Java browser, a browser in Java? And would it be even capable? It's not like just drawing text, but to draw images or whatever it would be at the time. And in truth, there was a browser, and for people not believing, probably, is this one. So this browser, it's named HotJava, and if you take a screenshot of it, it would look at least comparable with Internet Explorer 4 at the time, or 3, or Netscape. It has no tabs, but it would have even a working JavaScript engine. It would show GIFs or GIFs. You see here the earth is spinning. I look for a very old site. So this is the live site really working. So you can navigate back, front. It has obviously a lot of bugs, but nothing out of the ordinary. Or uh, you know, you could even act on clicks, and even it has this advanced feature at the time of setting a background. So it was an advanced browser, not the most advanced. It was not thought to be the most competitive browser, but it was capable enough at the times. Obviously, it was a bit slow, and we'll talk about this, for example, but it was really a reasonably featured browser. And why would it die? Some people would maybe ask. I would ask this if it would be me. And one part which we may think is what stack was using. So this browser was important for Sun Microsystems. That was the company which was making Java at the time, to show some other features. So for example, it would include what we name today Java applets, which greatly they died. But you could reuse the runtime to run these applets. So it could be both a browser and run some applets. It was also implemented with quite standard technologies of the time, but the fastest it could have. Like it was using AWT, which means basically you'll see native buttons. You had a just-in-time semantic JIT. For today's standards, it uses very little memory, but it was not true for the time. So that complex site I showed to you, it would use kind of 13 megabytes of memory, which would be a lot if you not be close to year 2000 or on a workstation. So the memory was a concern, and also you can find the source code more or less 90% compiling, but there will be some components which you have to get them somewhere from somewhere else. So you can't compile it from GitHub, but it's there, and you can play with it basically. And obviously, Sun killed it, and it was never revived. And I think the first talk it could be like what is the perspective of the even Java performance people talking about it, and they will say basically that desktop in Java it can't be done. Here's the full quote, and it says it's very good for web. The person likes to do web tuning on Java, but it says basically if you do a desktop GUI, you can't make it fast enough. And Obviously, I will say this person is wrong, but is wrong today. So when the book was written, around 2 years after Java, this HotJava was killed, uh, it would not be true. One part which some people would uh, consider that if the sun will just keep the same browser and it will just bump the versions of Java, it will get a lot of performance for free. So only in computation speed it could gain even between version 1.5 and 1.7 kind or 1.6 a factor of 2, and this is really impressive for free. And this would show in many places where you would think. So if even if it will not touch the code but let it just there to rot, touching nothing but just bumping the Java and make sure it compiles, as I said, with the latest code doesn't compile, it would give a lot of speed ups. In fact, you can look on Wikipedia. So from 1.1 to version whatever it is today, 18 I think, or 19, there are a huge number of very small incremental changes that change drastically how Java would work. And this will be really for free. Like, you just bump, you see it compiles, you fix one bug if it doesn't. The other part that it will be compiled and improved, probably this HotJava ran on AWT, so on basically native Windows controls, but you see that flickering, which is very annoying at least to me today. But the AWT was very compatible with Swing APIs, so just moving to Swing and again let it rot, it had a huge speed up. So it was GPU accelerated, and it would make itself like this browser to be GPU accelerated in year 2006, which will be basically the first browser on Earth. Before, I think IE9 was the first one which would promote like we are GPU accelerated. This will be the very first browser which will have that. And as I was saying before, the runtime had improvements, but there are many optimizations, and I'm thinking about escape analysis in particular, which probably it's worth its own clip once. It would improve a lot the responsivity of the application and reducing the garbage collection, which some people would complain because from time to time the application would freeze because it has to do garbage collection, especially on a lower end machines. So obviously this is easy to say than to do it, but I'm just thinking aloud that just improving, just keeping the code to rot and just improving a bit the virtual machine, it will have improving itself to being competitive more or less. But obviously some people will say, and what about the JavaScript? So the today pages are quite interactive, and an impressive thing is that there is a lot of research and work around JavaScript run on Java. So HostJava had a JavaScript engine, Mozilla had a Rhino engine. That engine Rhino was ported by Oracle with the JVM, and it made it very fast. And at last, today the latest effort is GraalVM, which depending on who you ask, it's basically kind of almost 80%, is 75% of the speed of V8 in benchmarks. And obviously the benchmarks are handpicked. This is basically the V8 benchmark suite, which V8 optimized for it. So it's the kind of best case for V8, but on the other hand, it really gives a very good performance profile. And I have also a personal interaction with GraalVM and GraalJS. So I'm using it I was using the GraalVM and GraalJS in a different way. And what I noticed it was that in one specific use case, I noticed that the slowdown was 20x slowdown or something like that. Very huge slowdown compared with V8, where V8 is the native JavaScript engine of Google. And in fact, it was fixed, given that I'm not a paying customer and so on, in a very fast manner. I think it was around 1 year, but and some people say how 1 year is very fast, but in fact it's very fast based on what it was implied. It was a medium probably refactor. I don't know how much work as a refactor was done, but it was not changing from value 2 to value 5 or changing a logical condition. But I understood that it was the way you structure when you cut big strings, and this change was making again kind of very competitive with V8. So my thinking is that the JavaScript engine again just bumped and used whatever was used upstream. You will have a competitive browser at the end. And with this of 3 items, so to have fast UI, fast runtime, and fast JavaScript, and GPU accelerated, it would make kind of always this browser, a Java written browser, competitive. And obviously some people will say, but this browser doesn't have tabs, so a person should have to implement tabs. Or this browser uses much more memory. And this may need to be addressed. Already Google Chrome is known to not use too little memory. So if probably this browser will use more, some people would complain. Or the GraalJS, it has a longer warm up, so it will take few seconds to become as competitive with V8. It is competitive, but it has some seconds for slowdown. So there will be still some hiccups, but in this case it looks like just people didn't maintain it. And right now obviously you are in a situation that will need really years to sort out all these bugs, but it's nothing that blocks it. Like nothing stops you to, not you, person to make a CSS parser with Java, and it should be fast enough, as fast probably as C++ one, again excluding the initial startup cost, which is typically bigger with a virtual machine, or whatever else they should be. Like let's say I'm looking here, like the ray trace benchmark, the Java wins or GraalVM, but in regexp it is quite slower depending on the implementation. It is kind of 80%, and some customers would complain, look, we really need fast regex. And for this place, I'm almost sure a person would report a bug, like I did myself. And if this would be very critical, it would be hopefully fixed. So at the end, to wrap it up, I think this is one opportunity which was lost. And the main reason why I think it was lost is that today we have many applications which were said they could not be done in a virtual machine. So for example, looking on this code base, the user interface is very responsive. Here's the cookies. applets, applet.js, and everything. It feels very smooth. Obviously it's in a faster machine, but letting aside how fast is the machine, it's quite clear. I think that users could have the same experience in a browser. And again, with a higher memory consumption probably than a C++ alternative, but very fast, very functional, and all the speedups will be gained for free, so it's not a big maintenance cost. But obviously there are in time other issues like conformance, performance, and so on. But in general, with a small effort, I think this is a case when it was possible, just it was not done. So let's wrap it up here. Thank you. If you like this kind of content, subscribe. It means a lot, at least for the algorithm, the YouTube one, and it will motivate me to make more. And obviously, if you find other subjects interesting, write them down and I'll be glad to write. Thank you, and bye bye.